So now let's switch gears. Let's talk about the generator gas dryer and why it's important and why you have an E1 generator gas dryer, or why you should get an E1 generator gas dryer. So the first issue we have is efficiency. As with higher dew points in your generator and your hydrogen gas, in this case, those higher dew points would be above 0 degrees centigrade, they increase the windage losses. And what that means is, we talked about hydrogen having the lowest density of any gas. Once the dew point gets to 0 degrees C and higher, that quantity of water vapor in the hydrogen starts to affect the density of the hydrogen. And that density impact results in a lower efficiency for the generator. The rotor is rotating through a denser gas. It's taking more energy to get to that same power output to the customer. So you're burning more fuel, costing the plant more money. You also have higher reliability. We want to reduce downtime at all costs. So a generator gas dryer is there to minimize these risks. And one of the main risks we have is stress corrosion and crack growth, particularly on the retaining ring. Another failure mode is associated with end winding failure and shorted rotor turns that are a result of insulation that has failed due to higher dew points in the generator. So two very key reasons, efficiency and reliability of your generator for having a generator gas dryer in your plant. So on the screen before you is a failure mode that we just noted. This is a failure of a generator due to retaining ring failure as a result of stress corrosion cracking. So it's a specific failure mode. Predominantly, it's focused on generators with retaining rings with 18 manganese, 5 chromium stainless steel. That material is extremely susceptible to this failure mode, but most stainless steels also. So we want to eliminate this failure mode by maintaining our dew points to OEM prescribed limits. So how does your gas dryer work? So the E1 generator gas dryer is a dual column dryer that continuously moves water from the hydrogen cooling gas. Having 2 columns enables the dryer to be drying on one column, while the second column is either in regeneration mode or available to be brought online when the drying column reaches its saturation point. We use a molecular sieve as the desiccant to remove the water vapor from the hydrogen gas. The GGD has a hydrogen circulator, and this ensures continuous drying even when we're operating on turning gear. So some systems out there may have a passive drying process, which relies on the rotor differential pressure to push the hydrogen gas through the gas dryer. Depending on the pipe work and the location of the dryer, the effectiveness of that flow will vary from plant to plant and even from day to day. The hydrogen circulator ensures that there's continuous drying at all times. And when we talk about the turning gear operation, if you're performing maintenance in your plant and decide to leave the generator on hydrogen while maybe you're doing work on the HRSG or on the boiler side of your coal-fired plant, this will protect that generator from having any condensation forming as the hydrogen gas cools down in the generator while you're performing that maintenance elsewhere in the plant. For the regeneration process, we have electric heaters in each column that are activated to remove the moisture from the molecular sieve. And we do that based on active dew point measurement. We look at the inlet dew point and the outlet dew point, and we optimize the regeneration to meet the customer's dew point set point. And that'll vary from OEM to OEM of your generator. So getting to know your E1 GGD a little bit more, one of the most important pieces of information that we ask for when folks are calling in with questions about their unit is the model and serial number. This information can be found on the system nameplate, and our system nameplates are located on the front of the large flame-proof enclosure. It's a large cast aluminum box in the bottom front of the gas dryer. And then there's a nameplate in the lower right-hand corner. And on that nameplate, we identify the assembly number, in this case, which is the model number, as well as the serial number, the manufacturing date, and some other key pieces of information. That information is critical to provide to us when you call in. It ensures we provide the most efficient problem resolution for whatever situation you're dealing with. And if you're just calling in for spare parts, this information ensures that we provide an accurate spare parts support for your needs. Some more critical information can be found on the gas dryer display. So on the upper front of the unit, there's a small display door. Behind that display door, there's the display screen you see on the window here. It has pieces of information. We have the inlet dew point, the outlet dew point displayed, and several LEDs that indicate different pieces of information to you. The lower right-hand corner of that display is a multifunction LCD display. And through that multifunction LCD display, operators can quickly gain access to some other critical information about your dryer, such as what software version you're running, what the version of processor you're running, the version of the I/O board, what the fault log is. So we record the faults in a fault log. So if you had an issue with your dryer, this is the place you would go to get that information and provide that to us. Again, specific to your unit, there's a software manual, and in that manual there is a stepwise procedure to how to gain access to the LCD and where to find specific information in the menu-driven event area of the software. So now that we've gotten to know our gas dryer, important to keep it running, important to maintain it. And the first thing is to keep an eye on it. Like any other piece of equipment you have operating in your plant, there's some daily checklists that we need to perform on the equipment. We'll walk through that here for the gas dryer. So again, we're referring here to that generator gas dryer display, which is behind the display door. The first thing we want to do on the daily checklist, we want to confirm that the AC power is on so that the LED is active. The next is to ensure that there is not a trouble alarm. So we want that LED to be not lit. If it is lit, then we've recorded a fault in the fault log. So you would access the fault log to identify what that issue is and then report that to E1 for troubleshooting accordingly. The next LED that's critical for us is that the motor on LED is active. This ensures that that circulating blower is active, circulating the hydrogen through the dryer. If that is not lit, again, there will be a fault in the fault log, and that would be reported back to us for troubleshooting. The upper left-hand corner, again, has the inlet and outlet dew point measurements, and these are reported in degrees centigrade. Again, we want to make sure that the outlet dew point is reading a lower number than the inlet dew point, such that ensuring that we have a reduction in dew point as the gas is flowing through our generator gas dryer. And in the lower right-hand corner, again, we're identifying the multifunction LCD display area. That's where the fault log would be accessed, as noted in your software manual, to provide that information to us for troubleshooting. So from a maintenance standpoint, we have a weekly checklist and we have an annual checklist associated with the gas dryer. The first thing we'll walk through is our weekly checklist. And the first activity we'll talk about is blowing down the vent drip leg. So we talked about the regeneration process of the dryer. What happens is the heaters come on, it drives off the moisture that's in the molecular sieve. We sweep that moisture up through the vent and out through the planned vent. Depending on your location in the world, what the ambient conditions are, that water vapor in the vent line will condense to some degree and flow back down the vent line. If you do not have a low point drain on that vent line, all of that condensation will form in a water collection area we have inside the dryer. Otherwise, we will only maybe collect some or a portion of that water vapor that condensed in this catch pot. So we have a level indicator, a sight glass that you can look at to see if there's water in the containment vessel. And then we have two valves on the front of the panel as indicated in the upper picture there. You would open those valves to drain the water out of the vent line. Now, if the dryer were performing a regeneration cycle, the opportunity exists while you're doing that drain for hydrogen to be present. It's important to follow all safety precautions in the plant for hydrogen venting in that area. The dryer is designed to operate in a hazardous area, so there is no inherent risk to the dryer. It's important to just follow safe plant procedures when it comes to the possibility of venting hydrogen gas during this process. We talked about checking the fault log in the previous slides. Again, on a weekly basis, scrolling through that to make sure any intermittent events that may have occurred are captured. You can stay informed of that and make appropriate plans for the next maintenance cycle when those opportunities arise. Now we switch to the rear of the gas dryer. On the back side of the gas dryer, we have on the upper portion is a manifold assembly with an actuator. On the underside of the manifold assembly, we have an inlet filter and an outlet filter. The inlet filter protects the desiccant material from any oil contamination that may be coming through in the hydrogen gas stream. And then on the outlet of the dryer, as the gas flows back to the generator, we have a particulate filter to protect the generator should any material be breaking down in the molecular sieve. We don't want that material getting back to the generator, so we collect that here. Both of these filters can be blown down on a weekly basis with the noted isolation valves. Again, as noted on the prior slide, the opportunity exists for some hydrogen to be vented when this occurs. Take all the safety precautions associated with that when these procedures are performed. The last weekly check is to ensure that their appropriate level of oil is in the gearbox. There's a sight glass on the hydrogen circulator on the gearbox side. The oil level should be about 50%. If there is a need to add oil, at that point you would follow the procedure in the manual to do that safely. And as we walk through these checklists, as Rachel noted at the onset, we do have a training video that we've prepared for you. Upon completion of the class, the training video will be made available, and then additional details associated with these procedures will be available in that video. So let's talk a little bit about the hydrogen circulator. It's a very critical piece of equipment to the generator gas dryer, and that it's always ensuring that hydrogen flow. And again, on turning gear, it's very critical that we're doing that to maintain the dew points during that critical time of the generator. But with all rotating pieces of equipment, it requires vigilant maintenance. So it's important to be up to date on the maintenance of your hydrogen circulator to ensure the performance of the dryer and the maintenance of the dew point in your generator. And the oil change is the most critical element of that. And depending on the model and serial number of your unit, it either has a quarterly oil change requirement or annual oil change requirement. If you're uncertain, call into our tech hotline with your model and serial number. We'll let you know where you are, what the program requirement is. And then on our more recent units, we've evaluated several different oils that provide a 1-year or annual oil change interval. That oil we can make available to you, and there's a software change that can be provided so that the oil timer can be extended to the 1-year oil change interval. From From an annual preventive maintenance perspective, we have a few additional steps that we want to cover here. The first is that we want to inspect the molecular sieve. It's important that we ensure that the molecular sieve is not damaged or contaminated. In order to do so, we have to remove the top lids of each vessel. So this procedure is taking place when the dryer is offline. So that can be done when the generator is still running. We have the opportunity to isolate both mechanically and electrically. The dryer can be isolated and put in a safe mode with a purge gas, and then the preventive maintenance can be performed even during those periods if the generator were online. Obviously, following all of the local plant safety requirements for that period of time. When we do remove those covers of the towers, there's a one-time use flexitalic gasket, so that needs to be replaced during the annual preventive maintenance procedure. At this point in time, we recommend calibration of the dew point sensors, both the inlet and outlet dew points. These are located on that manifold at the top rear of the dryer. So depending on the model and serial number of your dryer, there's a different maintenance protocol that would be provided, and we can walk you through what that is. One of the things we like to do and ensure during the annual preventive maintenance is to confirm that the vent flow is set properly, and that's at 2 standard cubic feet per minute. The flow meter that's located on the front panel is the flow meter that indicates how much hydrogen gas is flowing when the regeneration process is occurring. During your daily checks of the unit, most times you'll see no gas flowing in this flow meter. That does not mean you go over and open the valve fully. That means the unit's not in regeneration mode at that time. So this step is performed during the annual maintenance procedure. It ensures that the regeneration performed properly with the adequate flow. But once we do that, there's no reason to change the flow meter setting. And then the last step, as we noted, the criticality of is changing the blower oil. So even if you're on a quarterly cycle, when it comes time for the annual preventive maintenance period, you would be doing your fourth oil change of the year. It's important to note that we only want to use E1 approved oil, which is designed for use in the hydrogen environment to ensure that the maximum life of the blower and the absolute best performance of that blower is attained. So again, I noted pretty quickly through these procedures. The video will walk them through a little more detail. And as Rachel noted, the PDF of this presentation will also be made available to the attendees so it can be maintained for your plant usage. So to wrap up, we reviewed hydrogen properties and why hydrogen was selected for use for cooling the generator. We reviewed some of the hazards associated with working with hydrogen gas. We discussed what a hazardous area is, and we reviewed the best practices when working in a hazardous area. We discussed the importance of the generator gas dryer to your generator and to your plant. And then we walked through the maintenance procedures of your generator gas dryer, the critical ones and why it's so important. I'd like to thank you for your time today. It's all about safety, risk mitigation, and reliability. At this point in time, we'll take any questions you may have.
Okay, colleague, thank you for that excellent presentation. As promised, we'll start right in, and we've had a few questions come in. So we'll kick it off with generator purging generally done with CO2. What if we use N2 instead of CO2?
So so N2 can be used, and nitrogen is used. More and more plants in Europe, it seems, are using nitrogen gas. One of the considerations for using nitrogen gas is the hydrogen purity monitoring system that you have in place. So certain purity monitoring systems cannot differentiate the difference between nitrogen gas and pure air because of the very close densities and very close properties between oxygen and nitrogen. So if you're going to switch from a CO2-based purging system to a nitrogen-based purging system, obviously the first thing you want to do is consult your generator OEM and make sure that all of the appropriate boxes are checked there. But then looking deeper into the design of your system, the hydrogen purity analyzer needs to be considered, how you're going to detect the difference between air and nitrogen during your changeover procedure.
Okay, thank you. The next question, what parameter will alert you first, hydrogen purity or hydrogen dew point in case of any abnormality in the generator?
It depends on the failure mode. So the hydrogen purity reading is going to look for the ingress of air into your generator, which predominantly will come through the seal oil system. The purity meter typically will not detect the presence of dew point. So your purity meter is looking for a different situation. The dew point meter is specific to water ingress. So your sources of water, again, can be from the seal oil system. It could be from shared lube oil system. If you have a water-cooled stator, then the opportunity for a clip leak to bring water into your generator. The other opportunity for leak would come from your hydrogen coolers on the generator. So purity and dew point, for the most part, are looking for different failure modes, and they don't overlap at that point.
Okay, now will the dryer remove contaminants other than water, specifically nitrogen, which you already spoke to, but helium, argon?
Certain gases, the molecular sieve will adsorb. So I'd have to consult my chemical engineer to let me know. I know CO2 absolutely gets adsorbed by the molecular sieve, but there are other gases and species that the molecular sieve will remove from the hydrogen gas. So if we can take that, I could take that question offline with a little more detail.
Yeah, and so Stephen asked that question, so Stephen, Gus will be in contact with you directly for that.
Great.
So the next question, how common are generator dryers?
Well, they're getting more and more common. I think early on the industry was not putting them in place. It's an extra cost, an extra piece of equipment that the OEMs want to put in place. Customers, I think, are getting more aware of the failure modes of their generator, and certainly the insurance companies are getting more of aware of the failure modes and what the risk mitigation that the gas dryer presents. So we're seeing more and more of them in the industry today.
Okay, so Tim asks, even though my outlet dew point is lower than my incoming dew point, at what inlet dew point temperature should I start being concerned and investigate? What outlet dew point would initiate an investigation?
Okay, so the number that we hear in the industry that becomes a critical number is the 0 degrees centigrade. If your dew point is above that, there's certainly cause for alarm on your generator. When we go through the different prescribed dew points from different OEMs, we see -20 typically is a recommended, in that range is a recommended dew point to operate at. So the question about the inlet dew point on a gas dryer, if you have a large leak in your generator, a clip leak on a stator water cooling system or a hydrogen cooler leak, tend to be the larger leaks of water into the system. The dryer may not be able to regenerate quickly enough to keep up with the water ingress. So at that point in time, the water or the dew point rising. So I would think the trend is more the thing you want to be looking for. If your inlet and outlet dew points are trending up instead of trending down or stable, that would be the indication that you have an issue with your generator, because the absolute dew point that it operates at will be conditional upon how much water is getting into the generator.
Okay, how long does a dryer purge process take?
So purge, I'm assuming they mean the regeneration process. So a complete regeneration takes between 2 and 4 hours, depending upon the level of saturation of the tower. And that's specific to the E1 gas dryer.
Okay, and can you perform a service on the dryer while the generator is online?
Yes, and it's specific to the plant. So some plants, because hydrogen is present, they don't allow maintenance in the hydrogen areas, even when the generator is online. But the opportunity exists with the generator gas dryer. When properly installed with inlet isolation valve, outlet isolation valve, the unit can be completely isolated from the generator mechanically, and then electrically isolated at the panel that provides the power feed. At that point in time, we would be able to perform a nice safe purge using nitrogen or CO2 gas to remove the hydrogen from the dryer itself, and then the preventive maintenance or repair task that needs to be performed can be done safely.
Okay, and there was a follow-up to that last question. There were some clarification issues. So it's purging hydrogen out of the dryer, not regen.
Oh, I'm sorry, purging hydrogen.
No, there was clarification. No.
Yep, no, that's good. So purging 15, 20 minutes. We want to look for a minimum of two volume changes of gas flowing through the towers at that point in time. So depending on the regulator setup, the pressure you're delivering the gas at, you're looking at 30 minutes in that range to an hour max.
Okay, another question has come in. What to do if the generator dryer is under maintenance or under regen, say 4 hours, and a leak happened?
Leak.
I'm not sure I fully understand the question, but I'm pitching it to you anyway, Gus.
Okay. Well, if it's referring to a leak in the generator of water, again, the regeneration process is occurring concurrently with the tower being in service. So it'll continually be drying the generator. So if they're referring to a leak of water into the generator, we'll be able to remove that water, up to a certain point, depending on how big the leak is, because the regeneration process doesn't stop the drying process. We have the two towers for that reason. One is always in service by design. The second one is maintenance. Okay, so if we were performing maintenance on the gas dryer while the generator's online, and you sprung a water leak, a clip leak, and the dew point started rising in the generator. Obviously, it's cause for concern. It would all depend on the rate of increase of the dew point in the generator. Some plants, if you have a scavenging style seal oil system on your generator, you could increase the scavenging rate, and that way remove some of the high dew point hydrogen at a faster rate while you're performing maintenance on the dryer. And at that point in time, when the dryer comes back in service, restore your scavenging rate to the normal scavenging rate, and allow the dryer to make up for that water leak. But in the end, you're going to have to repair the water leak in the generator.
Okay, another question. What parameters dictate the size and/or type of dryer?
So the E1 dryer is one size fits all. So the amount of desiccant we have and the flow rate we obtain with the circulator, we can dry and maintain dew points on generators as large as 1,200 megawatts effectively. Again, it comes down to how big of a leak of water into the generator that we're looking to remove that water. In some cases, it's just the ambient conditions. The seal isn't that great or there's a shared seal oil, lube oil system, the opportunity for a lot of water vapor to migrate into the hydrogen gas. But in many cases, what we're overcoming is hydrogen cooler leaks or clip leaks on the windings on the stator cooled or water cooled stator systems. Colleague, did I lose you?
Sorry. Which seal oil system, no worries, which seal oil system is best for scavenging type or vacuum type?
Oh, I don't think there's a better system. I think it's by design from the start. The OEMs of the generator, of the power station, have elected to choose one versus the other. I personally, E1, we don't have a stance which one's better or worse. Our equipment works equally well on both systems.
Very good. If the inlet gas dew point is low enough, will the dryer go on standby?
So the dryer just will not perform a regeneration. We'll monitor the dew point, and if it's stable and below the set point, we will only perform a regeneration based on a time, and that's to ensure that the actuator cycles and that the columns are balanced for usage.
Okay, and do the heating elements in the columns ever need to be replaced?
By design, the answer is no. They're Canthal wire heaters that have a very long life. They can be field replaced, but they're designed to last the life of the dryer.
Okay, well, right now we have no more open questions. So I appreciate everyone who weighed in on some questions, and we'll just kind of end it here. But we want to, alert you to the slide that's up right now. If you wish to contact E1 technical support to schedule your dryer annual preventative maintenance today, there's the contact information. And as I mentioned in the a follow-up email that you'll receive, a copy of the presentation, as well as the generator gas dryer training video link. But Gus, hold on, because there's another question. Are these models can be used for hydrogen generation system? I don't know if that question's too clear to you.
Oh, yeah, we've had questions. So we'd have to look at the specific conditions of the hydrogen generation system to understand the parameters if there is a fit. So if that person who posed the question wants to send an additional series of technical details about their application, we're always, open to applying our technologies to other fields. It all comes down to, does the technology we have today fit the customer's needs?
Correct. So you'll have that you'll have that exchange offline then. And finally, any failure examples worthwhile to share? So that might be some saves.
I have the one on the screen that we showed previously of the retaining ring that failed. Luckily, from E1 gas dryer perspective, customers that are using our dryers have not experienced failures associated with retaining ring or the noted failure modes due to high dew points.
Excellent. Okay, colleague. Well, it looks like we're just about finished here. So on behalf of all of us at E1, we thank you for joining today's session, and we look forward to seeing you soon. We'll be sending out some more detailed information on our second of these series coming up soon. So look for that. In the meantime, be well.